Okay, once again, hello everyone from wherever you are joining us. My name is Jason Walls from QA Cafe, and I'm here with Zach and Tom, and we are going to be showing you the latest in CloudShark, specifically how you can use the tool called Zeek to help cut through network forensic data and get to the answers you need more quickly. They, between the two of them, they actually have over 30 years of experience dealing with networking and cybersecurity stuff, and they really do have a passion for it, and it's helped them helped us develop CloudShark and a lot of the solutions that we build here at QA Cafe to help build better networks. Zach is the CloudShark product manager and is responsible for a lot of the design work and definitely thinking about how we look at network forensic data and packets and how they all work together and how you can work together with teams to do so. And Tom is one of our senior technology specialists, and he is always diving deep into packets, learning as much as we can about cybersecurity and the workflows that help us solve problems that are revealed by having large amounts of network data at our disposal, and how to sort through it all. So without further ado, I will give things over to Zach.
Great, thank you. Thanks, Jason. Thanks everybody for joining us today. I'm coming to you from my home. I think Tom's coming from his. This is just the new world we're in. So at any point in time, the dog could wander in or something like that. But happy to be here talking to you about Zeek, talking to you about CloudShark and what's new, how we've integrated Zeek in our latest version. And today we're just going to go over a few things. One is just a high-level overview of Zeek. If you're familiar with it or not familiar with it, we're just going to show you what it can do, how powerful it is, all the great features it has. And then talk a little bit about starting your PCAP analysis with Zeek. From there, we're going to do some demos within CloudShark. We're just going to show you how it works, pivoting between Zeek Logs and the actual packets and how that's easy to do now within CloudShark. And then some additional reporting and sharing and collaboration across those Zeek Logs. With everything in CloudShark, we like to share. We like to have other teammates on the same page as us. And the new features with Zeek and CloudShark really make that easy. I'm also excited to introduce to some of you, perhaps some of you have seen it, but Little Bobby. Little Bobby is a web comic by Robert Lee and Jeff Haas. And so it's been around for a little while and I get a kick out of it. I think it's every Sunday a new one comes out. Some of them, it's sort of snarky. Some of it's hits a little too close to home, but it's really fun to sort of have a comic for the InfoSec space ourselves, So this is just how I want to start things off with. We've heard a lot about Zeek over the past few years. It was originally called Bro. So if you've heard of Bro or Zeek, the new name is Zeek. And it's been around for a decade or more. And it's a network analysis software that is incredibly useful, incredibly good at what it does. And so a lot of new tools now are building that in as a piece of their component and a piece of what they're basing their analysis on. And so that's why this was funny. So moving on. So basically, Zeek turns raw network traffic into comprehensive logs. That's its superpower. It can watch packets as they go across the wire. It can analyze a file after the fact, and it translates everything that it sees going on in a packet capture or on a network into metadata logs that can then be stored, analyzed, shared, and it's really, really good at those things. Typically, you think about network security tools or network monitoring tools, and they could be an active tool, and that's something like a Suricata or Snort or maybe a DPI firewall that's going to sit in the middle of your traffic and decide whether or not packets get through. Zeek is not that. Zeek is going to sit and watch your system passively as the packets go through and just observe things, write down essentially everything that it sees going through and report that later on. And so there's a lot of appliances out there now using Zeek as their core to handle this sort of passive viewing and letting you see what's going on the network, for better or for worse. A lot of times what you don't see can't hurt you if you don't know about, but Zeek is a really powerful tool for watching network traffic as it goes by. And there's several companies out there now looking at this on the passive monitoring space. So typically in that sort of passive monitoring, you've got a lot of Zeek sensors deployed around your network. They're watching packets go through and they're reporting back all this metadata to a centralized SIM someplace. This is amazing for threat hunting, doing sort of real-time analysis, gathering all that metadata together, and doing that, publishing everything into a dashboard. And so that's really great. You might not be capturing the packets full time when you're doing this because it takes a lot of memory and storage and it's expensive to capture them, but you're getting all this metadata and you're getting this wide, broad view of your network, which is fantastic. The other way we see people using Zeek, and this is where we've really focused our attention, is on specific incident analysis of a certain traffic event or something that's happened. So you've actually start with a PCAP, and you can take that PCAP and then run it through Zeek to get more detailed analysis of what's going on, a high-level view of what's happened, and it really gives you that great place to start. And this is definitely, we see a lot of expert command line usage. You're typically on a Linux command line doing this, you know, and using all your Linux tools at your disposal, whether it's awk or sort or grep or unique. And we'll talk a little bit about that also. This command line usage is also really great if you are using the sensor-based approach, where you have these sensors deployed with a faster configuration of Zeek, so you'll be able to parse traffic in real time. When something happens, you can duplicate that on your command line instance and dig in even deeper. And so that's something that we're going to show being able to do within CloudShark as well. So when you want to start looking at a PCAP, you know, a lot of us just open it up and start scrolling through packets, or we have some set of display filters that we like to click through, or, you know, filter buttons that we use. And really, when we start with Zeek, we get a whole different view of what's going on in that packet capture. So why would we do this? For starters, Zeek is really fast. It doesn't need to do the entire depth of the packet decode, so it can be a lot faster going through big, giant files. Like I said, it provides this broad, high-level overview of a PCAP. It sort of summarizes everything that it sees, and you can use that then to narrow down what traffic you're interested in too. So as you go through, Zeek will give you that broad overview. It's sort of like an index across all the different protocols and files that it knows about, which then you can then dig in deeper to those packets. We like to talk about CloudShark and other packet analysis tools as that microscope, and Zeek, you know, zooms you out a bit to let you see that. Zeek knows about a ton of stuff, and it's adding more and more all the time. So from a single Zeek run, and these are just the defaults. These are just the default logs that it comes with, but you get indexes of all the connections, all the services, different protocols and VLANs, full HTTP, you know, tracking of the user agents involved, the MIME types, the response codes, all the way through protocols, obviously like DNS or NTP, but all the way down to like looking for MySQL traffic or software versions, known hosts. So this is all out of the box what Zeek is capable of extracting from your PCAP file and giving you information for. There's also an additional package manager for things like JA3, which does some certificate analysis. And there's the package manager is called ZKG, and so there's a bunch of additional things you can add to from there. Basically, Zeek is taking a PCAP file and breaking it down into metadata. So from a command line perspective, and we'll talk about how it's worked on the command line before we dip into what we do within CloudShark. But you're going to run Zeek, pass it the name of a PCAP file, and if all goes well, you should get a list of all the log files that Zeek extracted from this PCAP, representing what's going on in there. So what is it? What do these things actually spit out? And so I had to zoom this screenshot out a little bit to look here. But this is basically the top piece of the connection log. There is a ton of metadata that comes out of a single PCAP file. For every connection that's in that file, you get tracked, you know, the source and dest addresses, the number of bytes that were sent, the numbers of packets that were sent, connection IDs, tons and tons of metadata. And what a lot of you do, and you'll be able to, you know, Google and read a lot of Zeek tutorials about all of this, but it's all text processing at that point. There's a great tool called Zeek Cut that sort of understands this header format a little bit to help you out. But really, you can just dive through and start piping it to your favorite Unix tools. It's all just sort of text analysis. So here's a great example when we're sorting through a connection log and looking at the number of response bytes. Sorting that by the maximum and taking the top 5. So this is essentially the 5 top talkers in this connection. But what happened to the PCAP file? We've got this great metadata, and I want to go back and see what's actually in these packets. And so that's where we've really added this within CloudShark. And so CloudShark already has all of your PCAP files stored within it. And what we're doing is bringing those logging capabilities of Zeek that are really powerful and really expressive metadata and adding those to your PCAPs. But even better, we're taking all that raw network data that we already have and that we're already planning on analyzing and getting back to it from your Zeek logs and associating it that way. So we're going to do a live demo. Tom and I are going to dive in. He's going to help me out with some analysis. We're going to look at a malware traffic sample. He can talk more about that. And just show how easy it is to run Zeek within CloudShark. Use some of our preset tables to get a lay of the land quickly and understand what's going on. But then essentially pivoting back to the packets and being able to see the raw packet data from the Zeek logs is what we really want to focus on. And then how to save and share some of those views for later. So we have a sample trace here, which I'm going to load up. It's on our hosted CloudShark instance. We will be able to send this link out to people afterwards. Little Bobby, of course, you know, most network problems, is it just DNS? Well, it could be. This one isn't, but we'll dive in. And so I'll bring in Tom right now, Tom Peterson. He and I work together a lot, and he helps me out with a bunch of packet analysis stuff. So Tom, what are we looking at?
All right. Hi, everybody. This is Tom from CloudShark. This is an example malware traffic analysis, PCAP. There's a website out there where, you know, they publish these examples. Essentially, you're given a PCAP, and the exercise is what happened.
Yeah.
There's
So
not a lot more information given beyond that.
Yeah. Where typically would you start with something like this?
You know,
a lot of packets.
Yeah, it's definitely a lot to scroll through. A great place to start is just who's on the network. Who are we talking about? You know, normally you'd see some sort of a private network, but just what are the local hosts on the network?
Yep. Yeah, I see some 10 addresses here. So this is a great place to sort of introduce Zeek and where Zeek can give us this overview really quickly. So it's a new analysis tool. The Zeek Logs analysis tool is in your menu for any CloudShark capture file you have open. And we click on it and it runs Zeek, and we can go in and explore all of these logs. And so here we are with, on the left, you see all those log files. And this is just like we'd run Zeek on the command line and spit out all of those logs. We have access to all of those here, all the metadata associated with them. And CloudShark additionally has gone through and created some sort of summary views that help clean up and sort of, you know, help streamline what you're looking at. So Tom, you were saying we sort of want to know who's on the network or what's going on.
Yeah, what hosts are on the network?
What hosts? All right, I think I'd seen, and since we have a Kerberos log here, this is probably a Windows domain or a Windows network. And so we can simply look at our client summary here and get a list of all the client Kerberos strings that came out of this capture file. And these are buried in the PCAP typically, right, Tom?
Yeah, there's a filter expression out there somewhere. I can't remember it off the top of my head.
So what do we have? Who do we have here?
Yeah, it looks like we can figure out now the domain that we're on. We're on frankandted.com. I see 2 machines, a desktop and a laptop, and it looks like also 2 users, Ted and Frank Borowski.
Ted and Frank. Frank and Ted, there they are.
Yeah,
so it must be their network.
Yep.
Yeah, so we get these summary views, we've sort of aggregated across them, really cleaned up a lot of the data that's in this much larger log file, just to show you these 2 things. What else do we want to know about for starting an analysis like this?
So the hosts that are local to the network, you know, just clicking on that, yeah, it looks like we can see we are on 10 network, just like we thought. But we see 3 IP addresses. We saw 2 Kerberos clients. What about that known services log right below it?
Oh, right below it. So yeah, so known services is now another way Zeek comes through and parses out the sort of the names of all the different services running and which IP address they're running on. So if you have web servers running or DHCP servers running, and in this sample, you know, what do we see?
Yeah, it looks like we've got, you know, that 1212 address as a DHCP server. Looks like it's probably also the domain controller. You can see that from the TCE service name. KRB is Kerberos. That looks like our main server on the network.
Yeah, definitely.
Yeah, so now we know, you know, the clients that are on the network and which server they're using.
Cool. Another great thing within Zeek, and this was something I've had a hard time digging through packets to figure out, but it's just what different versions of different software are we seeing running this thing? And so Zeek has this software log summary, which will break out different client versions that it figures out of software running on the host. And so this is a great example of that tool where, you know, I'll let Tom, you describe what we're seeing here.
Yeah, this is really cool actually. So here you can see, you know, those hosts that are on the network. We can see some of the software that Zeek has detected there. So we see, you know, standard HTTP browsers, kind of what you expect. We've also got what type of browser is running and the version numbers. Really cool to be able to see that, you know, it is part of the packet data, but to figure that out is usually a, you know, copy and paste, leaving the packet capture.
Right. You don't typically just have a packet that says, hey, I'm running Chrome 83.
Yeah.
You're gonna have to dig that out of other data.
Yep.
So because we're doing a malware traffic analysis, you know, something must have gone wrong, so we can dig in a little bit. And this is a great place to start. The first sort of thing I notice here is that this 203 address seems to be using IE 11 and Chrome 79. And I know once I switched to Chrome, I never wanted to use IE ever again. So that's a little weird, right? So let's take a look. So, and this is where the power of all the Zeek logs underneath this is really nice. So let's click on this row for MSIE 11. And Zeek tells us the full data for this row has this user agent string in here for what it saw going across the network and decided to pull out. And so we notice also, so we'll just look at that. This is Mozilla 4. Okay. We have in our HTTP log a summary of user agents. And so this is a really clean way of showing what user agents were seen in HTTP requests in this capture file, and then how many of them there were. And so we see these three user agents, and here's the one in the middle that I was interested in. This is the IE 11. And so we can click on this. There's 2 of them in this whole file. So let's apply those as filters. So we're gonna take the whole HTTP log and filter it on this user agent string, you know, with a single click of a button. And now we can scroll over to the side here and see the host, the method, and the URL that this user agent made. And, you know, I'm not sure what I'm looking at, Tom, so why don't you talk us through this?
Yeah, what's a little interesting, I mean, that URI looks pretty random, definitely odd.
Weird, yep.
But a DLL being retrieved over HTTP, that's a huge red flag.
Yeah.
To me. Wow.
That is.
That's where I want to dig in. Yeah.
Yeah. So this is a great spot to pivot back to the packets. So let's click on this first post because I'm seeing over here that it was a 302. There was no response length. I think I know what's going on, but let's click on this. And now we can immediately, with one click, pivot to the packets. And so this goes back to our CloudShark view of all the packets. And we can look at the request. And so there's a HTTP GET here, a 302, a DLL, but even better, I can just switch to our follow HTTP view. And let's see. Tom, what are you seeing?
Yeah, it looks like that GET request there right at the top. And the response that is being redirected, and the location it's being redirected to is just an IP address.
Ooh, yep.
Also strange. Don't usually see that.
Strange. No.
And it's a .dll. But if we
Somewhat
keep
suspicious.
going down a little further, yeah, that's probably far enough. That looks like a Windows executable.
Definitely.
Based on that, yeah.
It's MZ, and then you see this program cannot be run in DOS mode. If you see that in your HTTP logs, if you see that getting downloaded to a client, something's gone wrong. You're going to want to quarantine and figure out what's going on with that client right there.
Yeah.
Let's pop back to the Zeek logs here. And so we can see this post for the files, June 11 DLL. Let's open that up. And from here, we do see that response MIME type application .exec. So Zeek figured that out as well. Let's jump over to the files table that shows us a list of all the files that were seen in this PCAP. And from here, we can actually get the SHA-1. And we're just going to copy and paste that pop over to VirusTotal really quickly because this thing was downloaded. Let's just check the SHA. And yeah, I'd say that was not a good file to have. Not a good file to see somebody on your network downloading.
Yeah, it's a lot of red.
A lot of red. Not completely sure what it's doing or why or what, but yikes. So that's all from within here. So one thing in this VirusTotal, VirusTotal, if you aren't familiar with that, go check it out. It really goes through and talks about a lot of what viruses and malware do. Talks about behavior of this file. So what do we see? And here it talks about network communication, HTTP requests, the /post. And I know when Tom and I were looking through this earlier, let's go back to our HTTP request log within Zeek. We see that same /post URL showing up in our Zeek logs for this capture as well. So this is another, really good indicator that the machine that downloaded this file started making these posts and essentially is infected here. So let's use this chance to, again, pivot back to the packets and see what it's sending. So we can click on this post within the Zeek logs, again, filter our entire HTTP request file to here so we can see these posts. And this is a lot of data. I'm going to customize these columns too to sort of clean this up. I'm going to say multi-value, so any columns that are different across any value, but I still want to turn back on the method, host, and URI so we can see what those are. So we've got a bunch of posts, and they're getting back a lot of data. And so let's just start looking at them. We can start clicking here, and we can pivot back to the packets. And here's that post. And let's dig in, follow HTTP again. And so what do we do with this?
Well, to start, it looks pretty interesting. It doesn't look like text or something you'd normally see in an HTTP stream. Looks kind of like gibberish to me. I'd guess it's probably, encrypted or encoded somehow. It's probably, the malware using some sort of custom encryption.
Yep, definitely. So are we stuck? Will we ever know what this sent, or?
I've seen a few cases. There are some ransomwares out there that have been cracked. They've figured out some of the encryption that gets used. Same with some malware in general that just talks back to a command and control server. Even though we might not be able to decode it right now. At least we have the data that it sent. We know what was sent.
Right. So within CloudShark, I'm just gonna make an annotation. Here's one of the posts that was sent by the malware. So we'll save that annotation. It's gonna be associated with this PCAP everywhere. We'll get back to this view. And I'm gonna go back and do the same thing too. So now that we've sort of dug through and see, okay, yeah, this is bad. We're gonna see what's going on here. I'm going to go back to this, and we already have an annotation here because we were practicing earlier. But essentially, VirusTotal does not like this file. We want to save a note linking to our VirusTotal report within CloudShark on this packet. So we'll save that. And so now this view, this capture view here, and I'll show you the Zeek views in a second, but we can share these by URL with anybody else on our team. We can add them to our reports. We can add them to our wiki, our bug tracker, whatever it is. And now all the data and all of our analysis comes with us. So we've got a link to VirusTotal. We've got the packets involved in the initial infection. And we can go back, and to go back to Zeek as well, here's a list of all these posts that were made. I want to save this view as well. So I want to press save. And this is going to be HTTP post IOCs. These are indicators of compromise. And we'll just leave a little note. Here's all the different posts that were made by the malware. We'll create this view, and now that gets saved as one of our saved views. And we can copy and paste that URL, just like we did everything else, and copy that around, save it to our reports, and save that for later. So we'll be able to share that with people. They can jump right in here. Once, maybe someday there's a decryption key available, or we can understand the malware communication protocol, we can click on any of these, pivot to the packets, and follow this stream to see what's going on and start decoding the data. So we could know in the future what was exfiltrated or what was downloaded or what the command and control server was telling these machines to do. Lastly, real quick, there's one other thing. I just want to look back at our requests. And we did see this other request for this logs, invoice 86495.doc. And a lot of malware is spread through malicious Word documents right now, right?
Yep.
So let's dig in here. We're again, click on the row, apply as filters, open this up, jump to the packets. Like what's going on here? We see a status code 302. Let's see what happened. So we're gonna look at the get, follow HTTP, and Tom, why don't we see this file right here?
It'd be great to have this one because then we could actually verify where the malware came from. But it looks like it got redirected over HTTPS. So everything that was encrypted. Yep.
Yeah. So still encrypted. So we're not going to see it. Zeke's not going to see it as encrypted data. But again, as far as thinking about IOCs, we can also mention this, and we don't know for sure, but we'll leave an annotation. Could this be the source of the infection?
We could talk to
save that
and see if they have any files.
For sure.
That name,
for sure.
you know?
Yep. We'll see who downloaded that. This looks like it was downloaded by 12157. Where it was interesting that all the other traffic came from 12203. So it seems like both brothers are involved here. And that's just going to help our analysis when we continue on to go talk to them, go see what's on the machines themselves. Looks like somebody downloaded a malicious doc. Somebody else had some malware going on and talking to a C2 server out there. We need to have a meeting with them and figure out how to clean up these systems. There anything else we want to show right now? We get it all?
I think that's most of it. I really like that, just that IOC view, being able to send that to a, firewall team.
Yep.
So quick list of, block everything going to this.
Block this domain. This domain probably needs to be black holed when we're looking at stuff like that. Yeah, totally. And again, like Tom was saying, you can share this all directly from there.
You can add some links into that description and everything too, with some virus total links. Links straight to the packets. You mentioned how you can link straight to a packet view.
So Tom, what? Let me get my slideshow back going if that seems good. What does this do for you as an analyst when you're starting off?
Well, I like not having to remember really complicated filter expressions. I usually don't. So if I'm on someone else's, machine, or, I don't have them bookmarked, or I forget how I stumbled upon one. Even if you're just not too familiar with packet analysis and looking at that, traditional kind of Wireshark view with all the packets listed there, it's a great way to just click through those summaries. Get information about who's on the network, what software they're running. Don't need to do detailed packet analysis to find out Frank's running a really old version of Chrome, and I need to go tell him to update his software.
Right. Cool.
Yeah.
So this stuff's not easy to do. This XKCD joke is another favorite of mine. Like, networking problems are way harder than, regular problems. The joke before was, is it just DNS? But, there's a lot of strange things. We talk about, PCAP is the source of truth, but PCAP is just what we saw on the wire. It's not necessarily what happened on either end of each host too. So it's all part of the mystery. And what we're trying to do with CloudShark is improve network analysis for everybody. It's really hard to learn new tools, deploy new tools, get everything running all the time. Seems like the world's constantly shifting underneath us. And Zeek is just such a powerful, amazing tool. We wanted to add it to our stack and let people use it that easily. Because it really is hard to deploy all these things. So what have we done? So starting in CloudShark 3.8, for all CloudShark customers, you now have the ability to run Zeek from within CloudShark. It really is one click. We install it for you. We make it easy to run. You don't have to configure anything. It's all set up for you already. You just go to your analysis tools, Zeek Logs for any capture file that you have, and you immediately can jump into a Zeek view of the world. We've added some defaults and set up a couple extra plugins. One of the plugins we've added is Community ID, and that's a hash of the addresses involved in every conversation that's designed to be used across different tools. So that's really exciting to us, looking forward into pivoting into additional tools or across other pieces of CloudShark. And something else, another one we would highlight is JA3, which does some support for certificate hashing and analyzing certificate hashes, which is beneficial. If you can't see the encrypted traffic, you can do some meta-analysis of the certificates used, and that's what a lot of malwares, malware analysis is moving towards these days. And then we give you this completely web-based interface to explore and share those Zeek logs. We've added some preset views to clean up. There's a ton of data that Zeek produces, and it's all really valuable, but it can all be really overwhelming. So we wanted to show some presets that were easy to sort of get a high-level view of getting to cut down the noise early on. And really, it's pivoting back to the packets. The Zeek meta-analysis is phenomenal, but we want to be able to look back at that packet data and see those details and see those HTTP requests and see the post body that the malware was doing, or that the email was having problems with, or you find a TCP stream that has some latency problems. You can go back and do your TCP analysis once you've uncovered it and it's surfaced with Zeek. And everything can be shared with the URL. This is something we harp on a lot with CloudShark, and that is we want to be able to share all of our analysis. We don't want to do work twice. If Tom uncovers something and comes up with a list of IOCs, he can just send that link to me and I can have them, or it can be stored in a report. We don't have to copy paste. We don't have to store this data someplace else. If we want to come back in a month and research some more, it's all right there waiting for us. We don't have to recreate all our original analysis. Everything can be shared by a URL. And lastly, the big piece of this is that everything is still under the hood for Zeek for you to customize. We call this BYOZ, bring your own Zeek. And everything's still there. If you want to change out your Zeek versions, scripts, we didn't really get into a lot of the internals of how Zeek works or what it does, but it's all still under there. All we want to do is present those logs to you in a much easier to manage fashion. And lastly, we know this stuff is hard. And thank you for coming today and letting us talk about this with you and show you some of our new things that we're really excited about. And we're here to help. We're here to help the network analysis world, the individuals doing the packet analysis, doing the network analysis. And so, in a rare, non-snarky little Bobby, this stuff's hard, and everyone out there in security and network analysis is doing a really good job. And so, we're happy to be part of that community. So we've got a few links for learning more up here. Certainly our website will have some more content about using Zeek and some more use cases like this coming soon. The Zeek site is phenomenal. Their docs are amazing. They do such a great job. Go read some of their docs. Our traffic examples come from malwaretrafficanalysis.net. They post fairly often malware samples, which is sort of hard to get into the wild unless you've got an infected network. And of course, Little Bobby Comic, we want you to go check on that as well.